Good evening, everyone. I welcome you to this wonderful session. This is the mentor Hampel Kliman. Today we shall be looking at a 2023 science paper 2, of course, the chemistry part. Then we shall be able to answer questions under organic chemistry. And then we shall also be able to answer a question, usually that they like bringing on more concept in conjunction with organic chemistry. And of course, if you are new to this YouTube channel, consider subscribing, hitting the like button. Don't forget to share to others so that you can access more lessons that shall be uploaded on this particular channel. And of course, if you want to register for personal tuitions, make sure you text this WhatsApp number +26077664046. Let's get started. Now, the question is saying, alkenes are said to be unsaturated hydrocarbons. Explain the meaning of unsaturated hydrocarbon. Okay, so an unsaturated hydrocarbon is simply a compound containing carbon and hydrogen. Okay, let me write it. Okay, an unsaturated hydrocarbon is a compound containing carbon and hydrogen only with a double carbon to carbon bond. So a very good example of such compounds are simply alkenes. The alkenes family usually have a double carbon to carbon bond, and that's what makes them to be unsaturated hydrocarbons. So in comparison with alkenes are actually saturated hydrocarbons because they have only a single carbon to carbon bond. Okay, so an unsaturated hydrocarbon is simply a compound containing hydrogen and carbon only with a double carbon to carbon covalent bond. The next question is saying, distinguish between ethene and ethane. I want you to take note of what is happening. There you've got E. Here you've got A. One is an alkene. So this is an alkene. Then this is an alkane. What is the difference? The difference is ethene. Okay, so ethene has a double carbon to carbon covalent bond. Okay, it has a double carbon to carbon covalent bond. Wow. Okay, wow. Ethane. So ethane has a single carbon to carbon covalent bond. Okay, so that is the difference. Ethene has a double carbon to carbon covalent bond, while ethane has a single carbon to carbon covalent bond. So that is the difference. So when you write like this, they will give you all the full marks. Okay, all the full marks that you actually deserve. So this is exactly how you differentiate the two. We go to the next one. The next one is saying polyvinyl chloride is a polymer whose monomer is vinyl chloride or chloroethane, as we're able to see. And of course, do not be confused. Here there is supposed to be a carbon atom. Now they're saying we draw a diagram to show part of a polyvinyl chloride polymer containing 3 vinyl chloride monomers. So now, this is how it's going to be. You are going to have the first monomer, which is going to look like this. So the first monomer is going to have a chloride here, and then a hydrogen here, and then a hydrogen here, and a hydrogen here. Then you add it to another monomer, of course, which is going to have a double bond. It will look exactly like the one we have written. So this is going to be a chloride and another hydrogen here. Then we are saying plus. Okay, so this is going to be a chloride, this is going to be hydrogen, this is going to be hydrogen, this is going to be hydrogen. Now, what usually happens in the alkene family is whenever alkenes react, the double bonds will have to break. When the double bonds break, that is the only way that these guys would be able to conjoin to each other. So when the double bonds break, you expect that you're going to have a compound which is going to look like this. So you're going to have 6 carbons. 1, 2, 3, 4, 5, 6. So these are the carbons we're going to have. So 1, 2, then 3, then 4, 5, 6. Then you're going to have a hydrogen here. Then you're going to have a chloride here. You're going to have a hydrogen here. Then you're going to have a chloride here. You're going to have a hydrogen here. Then another chloride. Then underneath you just be having hydrogens like we have here. Okay? So the hydrogens atoms are going to repeat themselves. Okay? And basically, this is how a polyvinyl chloride polymer is going to look like. Okay? This is how it's going to look like. A polymer is just a large molecule which is containing repetition of monomers. Okay? So this is how it's basically going to look like. Okay. The question is saying, give one reason why polyvinyl chloride is used as an electrical insulator. So this one is actually very simple. It's because it lacks free moving electrons that would be able to conduct electricity. Okay? So you say because it lacks free moving electrons that would enable it to conduct electricity. Basically, that's the reason as to why it's very good for insulation. Okay? That's the reason as to why it's quite good for insulation. Okay? Don't forget that. We got to another segment of our questions, which happens to be C3. The following table shows the first 4 members of a particular homologous series. We have the compound, the molecular formula, and the relative molecular formula. Now, the question is simply saying, we state or we name and give the molecular formula of the next member in the table. So, of course, as you're able to see, this is butanol. So, the next one is going to be pentanol, right? So, the next one should be pentanol. Now, how exactly is pentanol going to be illustrated? So, this is what you're going to do. Okay? So, we know that our next molecule is going to be pentanol. Now, how is the molecular formula going to be? We know that alcohols actually flow by this formula. It's a CN, then H, 2N plus 2, then O, right? And pent is simply 5 carbon atoms. So you are going to put your 5 here. Then this is going to be H or hydrogen, then 2, then 5 inside, plus a 2, then like this. Then it's going to be carbon, 5. Then this is going to be hydrogen, 10, plus a 2, then oxygen. Then this is going to be 5, hydrogen 12, then oxygen. Now, how do you write it? All you have to do is simply to remove a hydrogen atom from the 12 so that it remains 11. Then one hydrogen is going to be put to oxygen so that you can have that hydroxyl group that is found in alcohols. So you're going to have C5, then H11, then OH. Okay, so this is going to be the molecular formula, right? So its molecular formula is going to be C5, H11, and then OH. Okay, that is how it's going to be. So make sure you take note of these particular questions. They actually bring the same things, and then you have to know how to solve them. Then they say determine the relative molecular mass of propanol. So this particular part. Now propanol, of course, has been given to be C3, H7, OH. Now they want us to find the mester. So to find the mester of propanol, we are going to say, okay, let me see. So this one is actually 2. So we are going to say C, or carbon, is going to be 3 multiplied by 12. So what is 3 multiplied by 12? It's actually 36. Then hydrogen, it's going to be 7 multiplied by 1, which is going to be 7. Oxygen is going to be 1 multiplied by 16, which is going to be 16. Then hydrogen is going to be 1 multiplied by 1, which is going to be 1. Then we now add everything in total. We see we have 36 plus 7 plus 16 plus 1. Notice that we're having 60 grams per mole. And this becomes our mester. So the relative molecular mass of propanol is going to be, okay, it's going to be 60 grams per mole. Okay, this is how you solve this particular part. Let me go to the B part. Let me just wrap the board. B is saying ethanol can be manufactured from either ethene or glucose. Construct a chemical equation for the production of ethanol from ethene. So they want us to create a chemical equation. Okay, so this is how your chemical equation is going to be for BI. You have your ethanol, of course. So this is going to be ethanol. Let me see, they're saying, okay, from ethene, very good. So now, notice that what happens is whenever you have an alkene reacting with water, you produce an alcohol. Now, the whole setup is very simple. If you have ethene reacting with water, you produce ethanol. If you have propene reacting with water, you will produce propanol. If you have butene reacting with water, you produce butanol. So for ethene, okay, which happens to be gas, when it reacts with water, which is going to be H2O, okay, or vapor, of course should be gaseous also because it's very hot, you are going to produce ethanol, okay, which is going to be written like this. Ethanol is an alcohol, of course, which is going to look like this, okay. So basically this is a chemical equation which is going to come out. Then they say using a named factor, explain how the rate of reaction for production of ethanol from ethane could be affected. So of course you would want to add a catalyst and eventually see how the production of ethanol is going to be rightly affected. So the catalyst you would want to add is simply, there are quite a lot, but you would want to add the most common one which you use, which is phosphoric acid. So an addition of phosphoric acid would speed up the rate of chemical reaction and increase the production of ethanol. Okay. We go to C. C is saying, calculate the maximum mass of ethanol that can be produced from 144 tons of glucose. So this part is actually what I really want to emphasize on the most. Okay, so B, of course, we've written our equation, so let me just grab it because it's already there. So we are finding C. Now, they want us to calculate the mass of ethanol that can be produced from 144 tons of glucose. I'm going to explain how you solve this particular mock concept the easy way. Okay? This is what happens. You first of all need to write a balanced chemical equation. So from glucose, C6, hydrogen 12, O6. How exactly are you forming ethanol? So ethanol, of course, you know that is supposed to be C2, H5, then OH, right? Then you are also producing carbon dioxide, right? So you are producing CO2. Now you just have to balance it and eventually see what you have. So let me see, you have 6 carbons there. Here you have 3 carbons. So you are supposed to put a 2 here. When you put a 2 there and a 2 here, you have got, let me see, 4 carbon plus 2, 6 carbon balanced. Then hydrogen, we've got, we've got 12 hydrogen. Let me see. Sorry. This is 10 plus 2, 12 hydrogen, 12 hydrogen. So hydrogen balance, let me see, oxygen. Here we've got 2 oxygen plus 4 oxygen, 6 oxygen. It's balanced. Now that we have balanced the equation, I always emphasize to students that whenever you are doing more concept, make sure your equation is balanced. Now that the equation is balanced, they are saying we are producing, want to calculate the maximum mass of ethanol that can come out from 144 tons of glucose. So we're comparing ethanol to glucose. So I'm going to get my glucose. I'm going to get my glucose and compare it with ethanol. Okay? Now, when I do this, the only thing that I need to do is to find the mixture of each compound. So let's start with ethanol. So it's going to be 6 multiplied by 12. What are we getting? Let me just punch this on the calculator. So it's going to be 6 multiplied by 12. So we're going to have 78 this side. Then, of course, hydrogen, we are going to have 1 multiplied by 12, which is going to be 12. And then oxygen, we are having 6 multiplied by 16. Okay, so 6 multiplied by 16, we're having 96. So 96 plus 12 plus 78. Notice that we are actually having, let me check properly. Okay, so for glucose, let me see. So this side we've got carbon. carbon 6. So let me see, 1 multiplied by, okay, 6 multiplied by 12, which is, sorry, this is, so I made a mistake somewhere here. It's supposed to be 72. So you have to be very careful with what you're doing. So 72 plus 12 plus 96. Okay, so we're having 180, okay, grams per mole. Now we have 180 grams per mole, so you can put your 180 here. Now we need to find for ethanol. So for ethanol, it's going to be 2 multiplied by 12, which is going to be 24. Then, of course, for hydrogen, we're having 5. So 5 multiplied by 1, which is going to be 5. Then oxygen, we're having 1 multiplied by 16, which is going to be 16. And then, of course, we're having a hydrogen there. So it's going to be, hydrogen is simply 1 multiplied by 1, which is going to be 1. Now, let's try to calculate everything. So having 24 plus 5 plus 16 plus 1, which is giving us a 46, right? So this is going to be 46 grams per mole. Now, we have a 46 grams per mole, but remember that you have these 2 moles. These 2 moles are affecting everything. So you would say this same 2 multiplied by 46, you are going to get a 92. So you're going to put your 92 here. Then you check this side. The question is saying you are using how many tons? Okay, 144 tons of glucose. So you're going to get your 144. You'll put it this side. Then this side on the other end, you are going to put your x. Then you cross multiply. You're going to have 180. X is equal to, so 92 multiplied by 144, you're going to get something like 13.248. 13,248 over 180 over 180. So your x is going to equal to, okay, so let me do this, divide by 180. So this is going to be something like 73.6 tons. Okay, this is what you're going to produce from ethanol, sorry, from glucose. Or let me just say, this is the amount of substance, or the weight of ethanol that you are going to produce from 144 tons of glucose. And this becomes your mass. So this is actually very simple. All you have to do is simply to follow the explanation that I have given. If you found this video interesting and helpful, don't forget to subscribe, hitting the like button, and don't forget to share to others. Thank you so much.